Hi, this is Amie at the Virtual Planetarium at Raritan Valley Community College. Let's take a look at some of the things we can see in the sky for the week of September 6th. Let's begin by checking out our upcoming moon phases. We have a last quarter moon on September 10th, a new moon on September 17th, and a first quarter moon on September 23rd. A last quarter moon rises around midnight and sets around noon. Of course, since we're in daylight savings time, add an hour to that. We've got the last quarter moon rising around 1 a.m. and setting around 1 p.m. That means the evening sky is free of the light pollution that the fuller moon brings. While it's also possible to see the moon against the blue skies of morning. Our sun is setting around 7:20 p.m. this week. About half an hour later, we can see something bright in our evening sky. Should you wish upon it? Well, you can, but it's the planet Jupiter. As it gets a little bit darker, you'll be able to see Saturn as well. 2 planets in our evening sky that we've been watching all summer. And the brightest stars that come out first are Arcturus in Boötes the herdsman and Vega in Lyra the harp. We see some other bright stars as the minutes go by and it gets darker and darker. The other stars of the summer triangle, Altair in Aquila the eagle, and Deneb in Cygnus the swan. Now, some people have a misunderstanding about stars and their brightnesses and their distances. Some people think that, we know the sun is the brightest star in our sky because it's the closest star to us. And that may lead some people to think that the next brightest star is the next closest star. And the next brightest star after that is the next closest star after that. And so on and so on. We can use stellarium to see if that assumption is correct. Let's start with Arcturus, because that was the first brightest star that we saw. We'll click on it and get some information here. The distance to Arcturus is 36.71 light years, plus or minus 0.22 light years. So there's a little bit of an error margin, and that's not too bad. What is a light year? It's a distance, not really a time. It's the distance that light travels in one Earth year. And we can calculate that using some math. Light travels at 186,000 miles per second. We want to know how far it goes in 1 year. So let's multiply that times 60 seconds in 1 minute, times 60 minutes in 1 hour, times 24 hours in a day, times 365.25 days in a year, and we get a really big number. It's about 6 trillion miles. So the distance to Arcturus would be, let's round that number from 36.7 up to 37. So 37 light years times 6 trillion miles, and I've run out of fingers. It's a really far distance. The number is too big for us to work with. So we created other units of measurement. It's like you would measure the size of your desk in inches, but you would never measure the distance from home to school in inches. You use a bigger unit of measurement, a mile. So we have a way of taking these big numbers and making them easier to work with. Now, here's where time comes into the picture. It takes time to travel these distances. Just like you might say it takes 15 minutes to drive to school, you used a time rather than miles. We use time for light travel also. The light that we see as the star Arcturus actually left that star 37 years ago. So the sky is like a time machine. A light year can be both a distance and a sense of time. Well, let's take a look at some of the other stars, because now I want to know how far away the other ones are. Let's look at Vega. Vega is 25 light years away. How about the other stars in the summer triangle? Altair is 16.73 light years away, almost 17 light years. That's closer than the other two stars. Is it brighter than Arcturus and Vega? Nope. How about Deneb? That's a bright star. Oh my goodness. Will you look at that? 1,411.93 light years. Wow. Now, there is a margin of error here of 1.71 light years, but we're still talking a distance between 1,400 and nearly 1,600 light years away from us. That is big. Those are huge distances. Okay, let us look at these numbers again. Arcturus, 37 light years. Vega, 25 light years. Altair, 17 light years. Deneb, 1,411 light years. So if distance always tells me how bright something is going to be, then something is wrong, because I'm seeing that the closest one is Altair. So Altair, in that thinking, Altair should be brighter than the other ones. And Deneb is so far away, it should barely be visible. But that's not what we're seeing when we look up at the sky. So we can't always say that the farther stars are fainter and closer stars are brighter. And that's because we've got different kinds of stars. Some of them are supergiant stars putting out lots of energy, including visible light energy. These stars naturally appear brighter than other stars that are closer, who aren't putting out as much energy. So that can mess you up if you are thinking that farther stars are dimmer and closer ones are brighter. That's not necessarily true. Okay, let's go back to our sky, and we're going to change what time it is. Let's go to our morning sky just before sunrise. It's about 5 a.m. We have our winter sky friends here, all the stars of the winter sky. Sirius is the brightest star in the night sky. And look at this. It's actually really close, 8.6 light years away. It's about 8.5 light years. So the light from Sirius takes about 8.5 years to get to us. Our sun's light travels 93 million miles, and it does not do that instantaneously. It takes about 8.5 minutes for sunlight to travel 93 million miles. What about Betelgeuse? Oh, look at this. 498 light years away from us. Wow, that's one of the brightest stars. Rigel's brighter than Betelgeuse, and it is 863 light years away. Holy smoke, these stars are really far away. Okay, let's look at our chart again of all these star distances. Arcturus, 37 light years. Vega, 25 light years. Altair, 17 light years. Deneb, 1,411 light years. Sirius, 8.6 light years. Betelgeuse, 498 light years. And Rigel, 863 light years. From looking at this list, we would expect Sirius as the closest star to be the brightest. And it actually is. But Betelgeuse is one of the brightest stars in the sky, and it's nearly 500 light years away from us. Rigel, even brighter, is even farther away. Maybe, instead of doing a lesson about how bright a star is and trying to figure out how far away it is, Maybe we should switch that up and say if we knew how far away it is, we could figure out how bright it is. If, for instance, if we were to set all the stars at a specific distance and then compare their brightnesses, that would tell us something different. And sure enough, if you put Rigel and the sun at the same distance from us, Rigel would outshine the sun. If we put Betelgeuse at the same distance from us as the sun, Betelgeuse would be a lot brighter than the sun. So there's a lot of considerations that go into understanding how bright a star is. So we need to learn as much as we can about the stars because there's more than just one trait to look at when you want to learn about stars. Okay, well that's our sky for this week. Thank you for joining me in our virtual planetarium. Please remember to subscribe to our channel and like our video. And we hope to see you at our real planetarium in the future. Until then, keep looking up.